Welcome back to the SSAS and MDX training batch 12 session 5. Okay. In last session, we discussed about how to create dimension and what is dimension table, what is fact table, or what is a measure group table, and what is an attribute and what is a measure, and how to create dimensions and how to create empty cube and how to add measure groups to an empty cube and how to add dimensions to the empty cube, right? We have seen all those stuff. And if you observe here, I've selected product, right? You can see there are so many attributes. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 attributes. Now let me go on browsing the queue and see how many attributes it is gonna show. Including the key, there is 9 attributes. Here 1, 2, 3, 4, 5, 6, 7, 8. It is showing only 8. What's the reason? Why one attribute is hidden? What is that attribute that is hidden? And what is the reason behind it? So let's discuss about that one first, which is very important property of a dimension. It's a must and should interview question if he wants to test you about SSAS completely. So if you see, first compare which attribute is missing. You can see color is there, French product name is there, and product key is there, product subcategory is missing. You can see product subcategory here, it's missing. Why? Because while adding the dimension, if you observe, I'm adding the dimension dim product again, just to demonstrate the property. I've selected dim product, click on next. And if you see, let me uncheck this. Let me click on next. If you see, product is by default selected, which is foreign key. Okay. And product subcategory is default selected, which is foreign key. But foreign key, if you observe the second property here, the enable browsing is checked for the first one, but enable browsing is unchecked for this one. What could be the reason for unchecking by default? Can you go for a guess? What could be the reason here? None of the answer is correct given by you guys when winning. Okay. The reason is, this is the foreign key. If you are gonna use this foreign key, okay, as part of your analysis, then for sure you are gonna add that dimension table or that master table which is having primary key product subcategory, right? Using this key column, you are not gonna do any analysis part. It's of sheer waste. If you want this product subcategory key related stuff as part of your analysis solution, that is cube solution, then what you have to do? You have to add the master table as dimension to the cube, right? Agree? When you add that, then obviously you will get this product subcategory key in that one. Correct? So there, as you can see here, it will be by default selected in that dimension. So why to have the same attribute in two places, providing for browsing? And he has not completely disabled it. He has given you option. If you want to analyze based on product subcategory key, and if you don't want to add the table which is having this key column as primary key, then you can check this. Now, if I click on next, it is added. These two are added. Now let me process the cube. I just enable the browsing browsing option for subcategory key. Let me process the cube. Oops, this is one headache. Let me give the password. Now done. Process is done. Let me close this. Okay. Now let me go to the browser. This is the cube browser. Let me reconnect. Oh shit. It is not showing here. What is the reason? What mistake I have done here? Why it is not showing? I have enabled it, I deployed it, I built it, I processed it, and attributes are enabled, still it is not showing in the browser. What is the reason? I reconnected it, I refreshed the browser, and Nisha, you are awesome. I have to add it to the cube. So this is my cube. I have not added the dimension to the cube. I told you that is created in the database level, and you have to add it to the cube if you want to make it available in the cube. I have not added it before. Now I have added it, and now let me click on process run. So browser. If I reconnect, that is available, and you can see both the attributes are available. So I enabled it while creating the dimension. Now what I have to do if I want to enable the same attribute for products? I want to make it available for the users. I want to make this attribute available to the end user. So to make, there will be hundreds of properties for every attribute. To see the properties, press F4. Okay, or simply select here and click on this window, properties window. The same will be enabled. Here if you see, there are two important properties here. Very important properties. Among the all, these two are most important. One is attribute hierarchy enabled. You can see it, the second one. And the second one, another one is attribute hierarchy visible. Okay. If you set attribute hierarchy visible to false, then what will happen is it will process the data. That means it will pull the data for this attribute. Now I set the visible to false for this attribute, right? You can see the property is false for this particular attribute, and for remaining attributes it is set to true. Now if I process this particular dimension, and if you expand this and see, somewhere here you can see product subcategory key, it read 39 rows. Means 39 distinct records are there. Okay. Now what will happen if I set the property, same attribute hierarchy enabled to false. If you see here, it is grayed out, right? It is not blue in color, the icon, it is grayed out. And if I process it, there are built-in errors, deployment, something, subcategory, the intermediate granular attribute should have attribute hierarchy enabled to false. I can't do for this one. I'll tell you the reason later. It will confuse you. So okay, here I'm going and enabling the property. I'm setting the property attribute hierarchy enabled to false. Let me process it. It won't throw any error now. Okay, and let me show you here. Same 39 rows are affected, right? You can see 39 distinct records are pulled. Then why we need to have two different properties, one with the name enable and another one with the name visible? Can you go for a guess? And if you see, both will not be available. Now this I disabled it, and if you see in the products dimension, I set the visibility property to false. You can see visibility to false here, and in product the enable property to false. And if I go and process the cube and see the cube, try to see the values in the cube, both will be disappeared. Nothing will be available. And if you see both are acting in the same way, then what is the difference? Now if you reconnect, you can see it is not showing the disabled one, and it is not showing the one which we set to invisible. Then what is the difference between these two properties, and why these two are very important? Any guess? So the difference is, if you set the enable to false, then you cannot use this attribute in your MDX queries. If you set the visibility to false, you can use the attribute in your MDX. So if you query based on this attribute, it will give you result if the visibility is set to false. And if the enable property is set to false, then you cannot query the data. Clear? And this is the reason why few attributes will not show even though you add it. Okay. When the attributes is not visible in your Q browser, just go and check the property. If the property of the visibility or visible or enable is set to false, it won't be available in your Q browser. Hope this answers to your question. And now let's continue with the next topic where we stopped in last session. Yesterday we discussed about creating the dimensions and creating an empty cube, adding measures and adding dimensions and measures to the cube. Now we stopped when we were discussing about dimension usage. By default, everything is set here. Why everything? How it has taken? Okay, this product is related to fact internet sales based on key. How it knows? How the SSAS server knows? By default, it will take. If you don't believe, let me delete these three guys. Okay. Now no dimensions right here. If I add a dimension, let's say I'll add product dimension. And if you go to the dimension usage, it is automatically setting and it is saying that, okay, dim product and fact internet sales is related using product key in the dim product table and product key column in the fact table. So it is automatically taking. What is the secret behind how the business intelligence solution, Microsoft Business Intelligence Development Studio is aware of this property, is aware of this relationship. So the secret behind this one is the relationships what we have given in data source view. That is why I highlighted if you design the data source view properly, then half of the work will be done by SSAS. The headache on you will be moved to the Business Intelligence Development Studio server headache. It will be the headache of the server. Okay. Now if you go here and see the dimension, this is the dim product which we are using to create the dim dimension, which we have used to create the dim product dimension. And here is your fact table. And there is a relationship which is saying how these two are related. The same relationship is there, right? If you see fact internet sales, dim product, this is the mass of, say product key to product key. If you keep this screen in mind for a few seconds, I'll show you the relationship page so that you can map it. If you go here and if you see the same dim product, fact internet sales, and these two are the same, the common columns what we have given as part of the relationship. And now let's see how it acts if you don't have relationship here. Let's say you have not given relationship in the data source view. You have missed that. Now let's see what will happen, okay, in the cube. Let me delete the dimension again and let me re-add it. When you add the dimension, it will take the measure group, okay, the table which you have used to create the measure group and the table which you have used to create the dimension, and it will go and check in the data source view here, and there is no relationship between these two. So it will say, man, I don't find any relationship, it's your headache. Either you provide relationship or not, it's your headache. Okay. If the relationships are properly given in your SSAS data source view, then no issues. It will take automatically in most of the cases. But if it is not given in the data source view, then you're gone case. Okay, be careful while defining the data source view. And people may ask, so many guys in my last batch, so many of my last batch students ask me, sir, what is the case? Why people don't give relationships in data source view? Basically nowadays in SQL Server itself, they made it as mandatory to create the relationships between master tables and child tables. Now no client will accept a database if you give without relationships. Agree? So why we need to worry about this? Automatically it will come into picture, right? Whenever you add it with the data source. That's the question I got from most of my students. But if you see Teradata, it won't have any concept called relationships. I work only on one project. I'm not good in Teradata. But as far as I know, there is nothing called relationships. It's like primary key, something is there. It's a different concept entirely. So if you add Teradata tables here, it won't have relationships, right? Then you have to give relationships here. If you don't give relationship here, then you have to suffer. You have to make sure that everything is related properly in the data source. Which is easy to give, which place is easy to give the relationship? Is it in the data source view or in the queue? In data source view, you just simply drag and drop. That's it. Get the product key and drag it into the product key. It will be set. If you go here, then you have to find out the correct relationship, and it's a big headache. You have to add the relationship type and then provide the remaining inputs. Okay? And database, if your database is Oracle or Teradata, and if there is no relationships in the database level, then no need to worry. Once you add the tables to the data source view, just drag and drop the relationship. You can always set the relationships between any table in data source view. Remember that point. You should not wait for a database team to create relationship. That's the best practice, obviously, creating the relationships in the database. But you have an option, you have a provision here to define the relationship on your own. Okay. So this is about relationships. If you see, the cube is nothing if you don't have relationships. And if the relationships are not given in the data source view, then automatically it will not be set. It's your headache to add the relationships. Now in this session, we are gonna discuss about the same. We're gonna discuss about how to set the relationships if the relationships are not defined. So let me remove all the relationships that I have here, and let's see how the relationships will be given and what kinds of relationships are there in in SSAS cube level. Before talking about the relationships that we are going to set in dimension usage, I'd like to add a couple of points regarding the database tables. If you take a table, let's say this is your master table and this is your fact table. How many times these two tables, how many different ways these two tables will be related? That we have to know. The first, that is purely dependent on the types of relationships between two tables. One is one-to-one relationship. Hope you know this one-to-one relationship. Another one is one-to-many. What is the third one? What is the third kind of relationship in database? It is many-to-many. Okay. What is one-to-one? First, let's see what is one-to-one relationship. We have to take Excel here to explain the same. Let me take the Excel. Let's say you have two tables. First table is employee ID. Is having these details: employee name and employee designation and employee department. And the second table is maintaining the remaining details of the employee. The remaining details in the sense is PAN number, his passport number, and something blah blah blah. There are so much of data. Let's say we are capturing. Okay. Now if a new employee joined, his ID is 1, name is Rupesh, designation is training, department is IT. The remaining stuff will be entered here for the same employee. So they have to maintain employee ID to join these two tables, right? Let's say one is given, PAN number is AEXPV something 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 something, and passport number is F46 something something something, and I have data in the remaining columns too. In the same way, when the employee 2 is joined, his name is Lokesh, let's say, he is module lead, BPO department, and his remaining details will be stored in the another table. Why? When the relationship is one-to-one, I mean This is complete master information. This table information as well as this table information. Why they are splitting into two? Why? Because the columns will be something around 60 to 70. So to make it, to maintain it in a better way, okay, sometimes they will split a single master table into two. Understood? Here you will have details of the employee ID 2. Now let me go to 3. Let's say Divya Kuchipudi. She is a project lead. Department is junk. And her details will be given here. Okay. Now, what is the relationship between these two tables? How these two tables are related? How can you say one to one? One to one in the sense, one record in the first table will have only one mapping record in the second table. One record this to this to this, right? This is called one to one relationship. This is one way of maintaining data in tables. Now let's see the next way. This is fine, one to one is fine. Now I am maintaining one more table to capture the leave details. Okay, leave ID, number of days, approved, employee ID. We need employee ID, right? Which guy has taken it? Okay. Now leave ID is 1, number of days is 2, approved yes, employee ID is 1. And Rupesh, he takes leave very frequently. And 2, 3 days again, approved no. 3, 4 and 5 days, approved yes. And here only 1 day, approved yes. And here comes the other employee. He has taken 2 days. Is it approved? Yes, it is 2. 2, not approved. 6 days, record 6. If you see this relationship, we call it as one to many. Why? Because here one record will have either 0 or more than 1. 0 to many. Okay. Any number of records can be here. If you see Divya Kuchipudi has not taken any leave, that's why no records here. 0 records here for Divya. Okay. And 4 records for Rupesh and 2 records for Lokesh. And we call this table as transaction table. Right? This is the transaction table. Here also you can have generally in one to one there will be one to one, and you can have 1 to 0 also. If there is no record in the destination, sorry, in the second master table, it is possible. It is not mandatory. It will be 0 to max 1. But if you take this transaction table, it will be 0 to many. And the third way is one record will be here. This guy have more than one. Okay. And this second record will have more than one here. That means this guy has many records here, right? 1, 2, 3 records he has. And the second record is also belongs to the second record here. So that means many to many relationship. Can you tell one example for many to many relationship? Think about all the different businesses and come on, just tell me one example. Don't say books and authors. That's a routine example I gave in training sessions to make you guys understand easily. Tell me any other example in which we maintain many to many relationship. And the data is in many to many relationship. Super good examples, man. You have given the cousins in the family relationship and students to the course, account number, banking product, loan, SBI account. Yeah, even this is, no, this is not, man. One account will be only for one guy. One account will not be shared for 100 of users, right? So this account will not work here. If you take cricket, it is the best example also. Dhoni plays for Chennai Super Kings, he plays for India. In the same way, Sachin plays for Mumbai. So team-wise, different players. and player wise different themes. You can take retail business also. Everything. If you take any business, at least there will be 1 minute to minute kind of relationship, right? Kind of data. So it's not limited to one. So now we have seen different types of tables, right? Now tell me, if this is your master table, okay, and this is your transaction table, and these two will be related directly, right? And how this table will be related? This can also be related directly to this, correct? And let's say there is one more table which is having relationship to this, but not directly to this. Then how can you join these three tables? I'll show you an example in SQL Server Management Studio. Okay, then you can understand. So if you take SQL Server Management Studio and AdventureWorks database, let me take database engine, and let me erase all the drawings from here. Okay, I've selected AdventureWorks. Now if you take select star from fact internet sales, this is your in fact table or transaction table. Select star from dim product. So this is your dimension table, and these two are related directly through column product key. There is a common column between these two, that is product key, and these two are related. Now let me take one more table. Select star from dim product subcategory. How the subcategory table, if you want to see subcategory wise sales, how you can relate the subcategory table and the fact internet sales table. What you are going to do here is, you are going to join this table with this and this table with this, right? In SQL for concepts. Now let me add one more table. Select star from dim product category. Now if you want to have the relationship between these four, then category and subcategory will be joined, and subcategory and product will be joined, and product and fact internet sales will be joined. So this is how there will be chain of tables, chain of master tables. And if you add the same in your SQL Server, SSAS data source view, then you can clearly see that. Now I'm going to add all these tables to the data source view. Already I have fact internet sales table. Let me refresh it so that it will add all the relationships. Oops, no changes have been done. Okay, this is a product is not a table, right? It's a, oops, shit. 1 second guys, I have done a mistake. I deleted it. Now everything is gone for a toss. No table, no dimension, nothing now. Okay, I have fact internet sales. I'm taking the related tables. I'm getting so many. I don't want all these at this point of time. So let me remove all this stuff. I'll take only product, and I will add the related tables again. I'll get dim product subcategory which I want, and I'm clicking on dim product subcategory. I got category. Now if I arrange the tables, you can see the fact internet sales table is the transaction table for your analysis purpose, and this is directly related to product, and product is related to subcategory is related to category, right? So if your requirement is to get the data based on English product category name to sales amount from the fact internet sales, then how can you relate these tables? In SQL Server you can use joins, but in SSAS you will use dimension usage relationships. There are 4 to 5 different types of relationships, and we are going to discuss about how the tables are related in SSAS cube. So before jumping into that, let me explain you a simple concept which is very important as part of interview. If you, I mean, it's an important interview concept, that is schemas. Data source view schemas or database schemas. Generally people ask how many types of schemas are there and which one you followed in your last project and why you followed that, which one is good in performance. You will get a lot of questions from schemas. Okay, let me give you a brief introduction about this and we can discuss a lot in further sessions. And here I'll tell you, there are two types of schemas. Basic types are two. Okay, one is star schema and another one is snowflake schema. And people define so many: universe schema, galaxy schema, and star flake schema. There are so many hybrid schemas introduced, but base are two types of schemas. One is star and another one is snowflake. What is meant by star schema? If you let me erase this drawing so that I can draw fresh. Star schema, in star schema, you will have fact table. Okay, fact table in the sense transaction table, and you will have master tables or also called as dimension tables. Okay, let's say you have 3 dimension tables. When everything is directly related, this directly related to fact, this directly related to fact, then this directly related to fact, then this kind of schema is called as star schema. So star schema definition is when the fact table is directly related to all the dimension tables, then we call it as star schema. The key word that you have to use here is directly related to. Directly. If you see this dimension, let's say this is dimension 1, this is dimension 2, and this is dimension 3, dimension table 3, and this is directly related, these two, and these two are directly related, and these two are directly related. What is meant by directly related? It is nothing but foreign key relationship between these two tables. This dimension table to fact table, this dimension table to fact table, this dimension table to fact table. If you have a relationship like that, then we call it as star schema. Okay. If you have relation like, let's say you have 100 dimensions and all the 100 dimensions are directly related to the fact table. Okay. Then we call it as star schema. Let's say you have only 2 dimension tables and 1 fact table, and those two are directly related. Then also it is a star schema. It doesn't matter how many dimension tables are there. It should be minimum 1 and maximum can be n number. But each and every dimension table or each and every master table should be directly related to the fact table or the transaction table, which in other words it is nothing but every master table or the dimension table should have foreign key relationship with the fact table. So this kind of schema is called star schema. And how can you get star schema in data source view? What is the easiest way? If I ask you to show a star schema, how can you do that? So the best way of doing that one is remove all the tables, take only one fact table of your wish. Let's say here fact internet sales is the, and if you click on add related tables, the first level add related tables, what tables will be fetched? Only the tables which have relationship with the fact table, right? The fact internet sales table. And if I arrange it, you can see all the tables are directly related. This is directly related, this is directly related, directly. And if you see, if you try to draw a diagram, it looks like a star. Star will be looking good, not this worst like my drawing, but it resembles star at least. Okay, that is why we call it as star schema. So remember this definition. Star schema is nothing but when the dimension tables are directly related to the fact table, then we call it as, this is SSAS terminology. If they ask in SQL Server terminology, when the master tables are directly related, all the master tables are directly related to the transaction table, then we call it as star schema. Now let's see the next one, snowflake schema. Snowflake schema is nothing but, let me take the notepad again. And let me erase this drawing so that I can draw fresh. Let's say this is your fact table, and one dimension table is directly related and another dimension table is not directly related. See, there is no relationship between this dimension table and this fact table, direct relationship, but it has a long cut through some other intermediate dimension table, right? It is having relationship but not direct one. And if the few tables will not have relationship at all, and few dimension tables will have relationship to this, like this. This is dimension table to fact plus fact table, from here to dimension table, and from here to fact table. So this is dimension, this is fact, this is again dimension, this is fact. So if you see, the relationships are not direct. So the shortest definition for this one is the schemas which are not which are not star is called as snowflake. Then they will ask you what is star. Star means direct relationship. Then what is snowflake? Which is not having direct relationship. All the dimension tables or all the master tables in SSAS terminology, all the dimension tables will not have direct relationship to the fact table. Is called snowflake schema. In SQL Server terminology, all the master tables are not directly related to the transaction table, then we call it as snowflake schema. And in all the cases, we will talk about only one fact table. What if you have more than one fact table? Let's say this is one fact table. I have one more fact table here in the same database. This is having all the dimensions related. Let's say 5 to 6 dimensions are there which are related. Okay? And there is no relationship between these two. Leave it. So this is star schema. This is snowflake schema, which is residing in the same database. So we call it as star flake. That is hybrid of star and snowflake. So getting star from the star schema and the flake from the snowflake schema, jointly called as star flake schema. Okay. And few people added so many new things like galaxy schema, and you just search it in Google. It's not the base concepts. No need to worry about that. Okay. This is about schemas. And these schemas plays a major role in cube processing performance. Why? Because let's take two cubes. One cube is having star schema. One cube is having snowflake schema. Okay. If I create dimensions using these master tables and measure group using these, then everything will be directly related, right? Everything will be inner join. This to this inner join, 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 this to this inner join. It will be easy. But here if you see, if I want to see this data with this fact table data, then it has to join these and get the data. This is unnecessary join in the middle, right? Which is lengthening the process. The process of pulling the data will be increased with one more join, and the performance will be decreased. In the same way, if you want to get one attribute from this dimension and one measure from this dimension, it has to join to this, it has to join with this, it has to join with this. Okay, it has to join with this. Let's say I have one more dimension here joining this and one more dimension here which is joining this. Then from here to here it has to come, means it has to come in this way. It has to join all the tables to get the data, which is the lengthiest process, and obviously the performance will be poor. So if they ask you which one is good in performance, what will be your answer? Okay. Most of you guys answer star. Yes, it is star schema. Performance wise, the star schema is good. Then as an interviewer, my next question will be, if star schema is good, then why you are going for snowflake schema? Why you are using snowflake schema? As you said, if star schema is good, then every database design can go with star schema, right? Yes, you won't get the data like this. See, everything splitting up and getting it to one. if this is the requirement, if this is the SAS schema, you cannot go for many-to-many relationship at all. In real time, you cannot maintain many-to-many relationship kind of data. So that is why for many-to-many, you cannot have directly two tables, master and transaction table joining together. So it is not possible to design the database in star schema always. Star schema works out only for small databases. But for huge databases, you have to go for snowflake schema. And if you have, you can have relationship between these two or not, that doesn't matter. Okay. And if you see the snowflake, you can convert to star, as Ravi said, but always the performance will be very poor. It will be very poor if you convert it to star. It will be very difficult. Forget about the performance. Sometimes it's very difficult to convert as snowflake schema, but most of the times guys will try to denormalize the tables, and they will try to. When you will get lot of tables like this, you will get lot of tables when you try to normalize it. We discussed about normalization, right? Splitting of tables, right? One big table into many. So when you normalize the data, you will get all small tables, and it will go for snowflake. When you denormalize it, means making small tables to big ones, then you will get star schema or one single table at the end. So while denormalizing, it's very difficult to denormalize in all the cases. I showed you what's the problem you are going to get. You will get lot of junk data, lot of repetitive data. It's not junk, it's repetitive data. So to avoid that, we were normalizing the databases. And now if you denormalize it, then it will have lot of repetitive data, which will be performance hit. And it's also not possible always to convert from snowflake to star, keeping the complexity in mind. I'm saying this. If I want to connect these two, let's say if I want to convert a snowflake, okay, to a star schema, it's not a big deal. For example, this is your fact table. It has one dimension and another dimension, and here I have one more dimension, and here I have one more dimension, here I have one more dimension. So that means there is some relationship between these two and these two, right? I can use one inner join, take a named query, join these three tables and set it as one table. So this becomes star, this part. And these two tables join and create a named query by joining these two tables. Now it become a complete star schema. You won't see these two tables. You will see one named query instead of these two tables. You will see one named query instead of these three tables. So this is how you can convert a snowflake into star. But this is a simple snowflake. If you take the complex one, it will be very difficult for doing the same. Now and if you have more than one fact table here, then joining these two will lead to the performance hit badly. Okay, joining two fact tables, there will be no common column. First of all, there will be some common dimension for this, like this, here and here. You will take the common column from here and place it either in this table or in this table and join these two tables. You have to join so many tables, and it will be very hectic one. And instead of that, better not to design SSAS cube project. Okay. Now let's go to SSAS cube and how to see the relationships. First, we are going to see how to give the relationships when the dimension and the fact table are directly related. Right? What is meant by directly related? In other words, when the dimension table and the fact table are in star schema. Okay. Now, this is my data source view and this is my cube. And I'm going to create one dimension. I deleted the dimensions, right? So let me, oops, this is still there. Let me delete these guys. I deleted the table references, okay? Now let me create one dimension using dim product. Click on next. Let me select everything here. I don't want to be choosy here. And I'll give the name as products. So the dimension is ready. Before adding it to the cube, what I'm going to do here is, I'm gonna remove the relationship in data source view. Then only I can explain you, right? So let me go here, remove the relationship between the dim product and the fact internet sales. This is the relationship, and if I remove it, and now if I try to add the dimension to my cube, it will not set the relationship automatically. That's what I want here. Now you can see the relationship is not set. So now you know these two tables are related directly. And how these two, what is the common column between these two tables? It's product key. So let's see how to create dimension, how to create relationship between dimension and the fact table. First you have to click this. When you click on this, a button will appear here. Click on the button, this page will open, the define relationship page. And here it will show you the tables. Okay. The yellow one means fact table. The blue one means dimension table. The no relationship is the default one. It is set. The dimension and the measure group are not related. When these two are not having relationship, or when these two are not having common column, then this kind of relationship will be set. But we have a common column and we are going to set the relationship. How these two are related? Is it directly or indirectly? Directly. When these two are directly related, the relationship is called regular relationship. When the dimension table and the fact table is directly related, that means when these two are having foreign key in the database, then the relationship is called regular relationship. And when I select this, you can see the tables are changed, and fact table and the dimension table are having one relationship, direct relationship, and you can see the dimension table is joined directly to the fact table. Okay. Now comes the important point. First you have to select the granularity attribute. Granularity attribute is nothing but the primary key column of the dimension. That is why I said while choosing a dimension table, you need to have a primary key column. Okay, if you don't have it, will throw error. So what is the primary key column we selected for this particular dimension? While creating the dimension, you know, right, by default, when I select the table, the product key was selected. So the granularity attribute is primary key. That means I'm going to join my dimension table using the product key attribute. Okay. And what is the common column in the measure groups? It's product key. That's it. If I click on OK, the relationship is set. Let me explain you in SQL terminology. Select star from dim product table, inner join, fact internet sales on product dim product dot product key is equal to fact internet sales dot product key. Can you see SQL query here in the wizard? Just follow my cursor. Select star from dim product, inner join, fact internet sales on dim product dot product key is equal to fact internet sales dot product key. So this is the column from measure groups. That is, measure group table is fact internet sales. This is the column from dimension. That is dim product. So in a simple inner join, we are creating an inner join using this wizard. So this regular relationship is nothing but having a direct relationship. When you have direct relationship, this image will say everything for you. When you are having direct relationship, then it will be set using the relationship type regular. Is it clear? Now there are three more: fact relationship, referenced, and many to many, and data mining. I'll give you a brief about it today, and tomorrow I'm going to explain you about how to set the relationships. Data mining is out of scope for these sessions at least. When we discuss about data mining only, we can talk about that. Now we don't need to worry about it. Let me give you a brief about fact, referenced, and many to many. Okay, fact relationship, you know regular now. Okay, now fact relationship means you can see the image. The dimension table is the fact table. That means both the dimension table and the fact table are same. I have given you an example in last sessions. Can you recollect that and tell what the example I have given? In which the dimension table and the fact table is the same. Exactly. It is color-wise product count. What is the dimension table? Color attribute is coming from dim product. Count is coming from dim product. So if you see, both the fact table and the dimension table will be the same. So that kind of relationship is called fact relationship, and we will see how to set this in tomorrow's session. And the next one is referenced. If you see the image, it is pretty clear. This dimension is not having relationship with the fact table, direct relationship. If you see, it is marked one, right? It is dotted one. So this guy is not having relationship with this directly, but indirectly it is having through some other dimension in the middle, right? We discussed an example about this while discussing about snowflake schema. So dim product subcategory will be joined with, let's say this is dim product subcategory, and this is dim product category, and this is your fact internet sales, right? So when the dimension table is joined to fact table using some intermediate dimension table, then that kind of relationship is called a referenced relationship. Okay. Now let's see the last one, many to many. You can see the image. The image is pretty clear. This is your dimension table and this is your fact table. These two are related through two different tables, one fact table and one dimension table. So when you have a data like this, when the data is in many to many form, then you have to go for this many to many relationship type. Okay. So these are the three different remaining relationship types that we need to discuss in tomorrow's session, and we will discuss this in tomorrow's session, and we will also discuss about couple of dimension properties and dimension types in tomorrow's session. Before concluding this session, I would like to give an assignment to you. You have given good examples for what is that? Many to many relationship. I want you guys to create tables and load some data in which the data is many to many type. I want the table should have relationships and data in a proper way. Just one set of many to many data. That's it. I want to have tables with many to many data, and I should be able to see, let's say you have one table here and one table here. These two are many to many. Okay. Let's say I'm giving an example, but this may be correct one, may not be. Just giving an example. So this is many to many, let's assume. I should be able to see, let's say here is a book one. If I want to see book one, who is the author, I should be able to see here. In the same way, author, what is the books, I should be able to see here. In the same way, take n number of tables. I don't bother about that. But the relationship should be proper and the data should have many to many relationship. That's the assignment for today, and hope you will not neglect it. Okay. And that's it for today's session, and I'll catch you in tomorrow's session. Have a nice day, guys. Bye-bye.